This is our galaxy, the Milky Way. This is our galaxy, Channel Does. This is a part of our universe's drum. Our connection with time is ancient. Other galaxies' railways are not found much here, but the Milky Way is. It is millions and billions of times bigger than them. Galaxies are found, and at the center of all of them is what drives these giant galaxies. A supermassive black hole, the Lord of Darkness, which is one of the greatest mysteries of this endless universe. As far as we have come to know black holes, they have always been a center of attraction for all of us. The most mysterious and so vast that there is no need to even describe their power. These cosmic giants are often described as terrifying. They remain hidden at the centers of galaxies. These unimaginably powerful giants have been visible to us since we began peering into the history of the universe. Ever since their existence, scientists have only recently found such evidence, which tells us what is epoxy black actually like. They existed in the early universe much earlier than we thought. This discovery could change our understanding of the early universe. After all, what were these mysterious objects doing right at the very beginning of the universe? How did they form so quickly? And how did their evolution happen in that early universe? Astronomers have been puzzled for a long time about the presence of quasars in the early universe. The discovery of quasars in the early universe means that supermassive black holes existed there, and this conclusion surprised scientists even more. These observations have raised many questions. The early universe, which was not even a billion years old yet, how could supermassive black holes possibly form there when they didn't even have enough time to grow and evolve? So were they born as unusually massive giants, or did they somehow learn to grow very quickly, breaking the rules of the universe? A study has been published in the astrophysical journal Letters using data from the Hubble Space Telescope. And this study has revealed that the early black holes were less luminous and were growing in a universe filled with darkness. Because of this characteristic, they have remained hidden from our view until now. This astonishing discovery not only deepens this mystery even further, but it is also providing us with a lot of new information about the formation of black holes. Let's go on a journey of black holes today and see how these black holes were forming in the early universe. We will also take a look at what the James Webb Space Telescope has told us about black holes. So get ready to embark on an exciting journey filled with the mysteries of this universe. The mystery of early supermassive black holes is one of the biggest mysteries in science so far. It is one of the puzzles. How did supermassive black holes come into existence right after the Big Bang? Quasars, which are among the brightest objects in this universe, are powered by giant black holes. Scientists have observed these quasars in galaxies present in the early universe. When the universe was not even a billion years old, these objects grew so much within a billion years that they became supermassive black holes and formed quasars. It's not even possible. It's like if I ask you, have you ever seen a 10-year-old old man? You'd say, how can someone be born and become old in just 10 years? Even scientists are puzzled after seeing this same case. If they had so little time, how did they grow so much so quickly? When it comes to black holes, they grow by swallowing the gas, dust, and other things around them. All this matter gathers in the accretion disk of the black hole, and from there, little by little, it keeps getting absorbed into the black hole. As this matter falls into the black hole, it keeps colliding with the other dynamic material present in the accretion disk. Because of this friction, it gets heated up. And that's why intense radiation is released from the entire accretion disk. This radiation creates a pressure barrier, and a limit is placed on the black hole's matter consumption, which directly affects the black hole's growth. Considering this limit, scientists are unable to explain how, despite this limit, black holes became so massive in such a short time back then. Given by scientists, there are two possible solutions to this. Either these giant black holes were formed from a stellar mass black hole, which are the remnants of a massive star, which die very quickly, so they take less time to reach the stage of a supermassive black hole. But if this process speeds up a little, then they can grow within a given limited time. Now, since their beginning itself is with a mass 1,000 times heavier than our Sun, that's why they're also called heavy seeds, and because of this they quickly reach a larger size. But where did these heavy seeds actually come from? One theory suggests dark matter halos. These are structures made of invisible matter that hold galaxies together. These structures also trap a large amount of gas clouds and prevent those clouds from turning into a star. When stars do not form from those gas clouds, they collapse directly into a black hole, which creates a very heavy seed. There is still a minor problem. Only a few dark matter halos have been found to be large enough to trigger direct black hole collapse. Black holes formed in this way should be found in very small numbers in the early universe because the dark matter halos that create them were themselves quite rare. But recently a new one has not appeared. Research shows that the number of black holes we have observed in the early universe is much higher than our calculations. And because of this, astronomers are now forced to believe that some very mysterious forces were at work in the early universe, because of which our current science is not able to understand them. Now, how can it be that there are black holes and there is no mystery associated with them? Because of advanced technology and GWSD discoveries, now astronomers are able to find black holes hidden in galaxies present in the early universe. Earlier, we could only detect those bright quasars because they are very bright. But recently, observations from the Hubble Space Telescope have discovered many faint black holes that had remained hidden from us until now. Scientists monitored 15 years of brightness data from galaxies, which shows that they are quietly growing in the universe. They have also become capable of estimating black holes. We have been given new data which shows that the number of black holes we previously assumed, in fact, their number in the early universe is many times higher. James Webb Space Telescope has taken this discovery even further. Thanks to its extraordinary sensitivity and advanced spectroscopic capabilities, James Webb has also started hunting faint black holes in the early universe. It is closely monitoring their activities. This telescope is also capable of detecting the faint glow of black holes hidden within galaxies. This will help astronomers refine our early models of the cosmos. But then this raises another question. If there were so many black holes present at that time, then how did they all grow so quickly? After all, where did so much matter come from for them to consume? According to scientists, the answer to this might be hidden. In mealtime variability, unlike stars, black holes do not grow continuously with their eating habits at different times. Instead, they keep a gap in their eating times. They take breaks, which makes it difficult to estimate the actual rate at which their size increases. Black holes trick us here as well. This discovery is also groundbreaking because it contradicts our previous model. This means that it proves the model we created to be wrong. Scientists now believe that all the black holes discovered so far, from extremely bright quasars to the recently discovered less bright black holes, there are so many of them that they couldn't all have formed through direct collapse. This suggests that there must have been some very mysterious processes at work during that time, which were not only creating these black holes in large, bulky quantities. In the next 5 years, the James Webb Space Telescope is going to play an important role in solving this cosmic puzzle. Its ability to observe faint black holes also gives scientists the power to witness the death of the first stars. And this event can tell us where the initial seeds of black holes came from in such large quantities and how the universe continued its journey forward. Apart from the standard theories of dark stars black hole formation, scientists are now considering even more bizarre ideas to somehow explain the black holes of the early universe. And one of these bizarre ideas is the concept of dark stars. However, dark stars are completely hypothetical, meaning they are imaginary. This star forms when a large cloud of gas begins to collapse. Just like a normal star forms? But when dark matter is present in that normal star formation, something mysterious happens. As soon as the gas present in the cloud contracts, that is, it shrinks. It captures the heavy amount of dark matter particles, and these particles are in the process of forming normally. It modifies the internal structure of the star in such a way that the process of nuclear fusion at its core stops, which is what makes stars shine. Without the fusion process, this star cannot shine like a normal star. But it lives much longer compared to those stars and becomes very unusual. And eventually, these stars collapse under their own weight and turn into a black hole, which are much bigger than any normal stellar mass black hole. It's interesting to think that if these objects existed in our early universe, then they were observed by us. They can explain the observation of a large number of black holes. However, dark stars are still a theoretical concept for us, an imaginary idea. But large telescopes like James Webb Space Telescope can play an important role in proving the existence of such stars. Observing the collapse of those early stars with our telescope, it can tell us whether dark stars played a major role in black hole formation in the early universe or not. This adds another exciting possibility to the growing list of questions about these black holes. Are there some processes at work in the universe that we don't fully understand yet? The future of black hole research holds great potential for such fascinating discoveries. In just the past few years, there has been a revolution in research in this field. Upcoming missions like the Euclid mission and the Nancy Grace Roman Space Telescope will help not only in observing faint black holes, but also in detecting faint quasars. Meanwhile, observatories like the Square Kilometre Array or Square Kilometre Array being built in Australia and South Africa will help us understand black holes in greater depth. But for now, Jadwalski is leading this research. By observing some of the faintest black holes in the early universe, this is helping us refine our old models. In the coming years, with his help, we will also be able to find a collapsing star, and that discovery will be historic. We are trying to learn about and understand our own history, but perhaps the universe is such that whenever we get close to understanding its origin, along the way, new questions arise before us. James Webb Space Telescope is revolutionizing our understanding of the early universe. It is revealing the distant galaxies and the cosmic processes happening there to us in astonishing detail. But not every one of them. Along with the discoveries, it is also presenting us with some controversies and very big questions, especially about a very important epoch of the universe, the epoch of reionization. Reionization is a very important time in the timeline of our universe. Reionization is that time when the first few stars and galaxies of our universe together changed the entire map of our universe. They fundamentally transformed the universe completely. After the Big Bang, our universe was dark, but there were stars and galaxies. Why either the stars and the galaxies? The rise of our universe has ended. It is believed that this dark matter formed just a few years after the Big Bang. It ended about 50 million years ago, which led to the creation of our era. Now questions are being raised about the models. Have we really understood everything we've read about the birth of this universe so far? Were all those things accepted by us? The big theories that have been built on the basis of these models, are they all wrong? In today's video, we will break down the reionization period and find out how. James Webb Space Telescope, its discoveries are creating tension among cosmologists. And how could they not? Theories can help us explain these surprising results we're getting from James Webb Space Telescope. Is it possible that all the models we've made about the early universe are missing a lot of important information? Or have we always been making a big mistake in defining this universe? Let's find out how JWST can help us rewrite the rules of this universe. And what could this mean for the origin of our universe and for our own species? What is the epoch of reionization? The reionization period is one of the most important periods in the cosmic history of our universe. It started about 100 million years after the Big Bang, when the first stars and the first few galaxies started forming in the universe. Those stars had started emitting intense radiation, which was so powerful that it was enough to break hydrogen atoms. This radiation broke those early hydrogen atoms into protons and electrons, and this process of reionization gradually spread throughout the universe. Because of this, our universe went from a neutral state to an ionized condition. The universe, which used to be cold before, had now become hot. Hydrogen is the most abundant element in our entire universe, which is why the changes that occurred in the universe during the reionization period were very profound, which was directly affecting about 75% of the matter present in it. During this period, the gas present between the galaxies that were forming had become completely transparent. Because of this, light got a chance to escape, and during this time, for the first time, light was able to travel freely in this universe. These changes were very critical because the galaxies we see today, this is what shaped those galaxies, those Milky Ways. And this has determined that these structures in the universe can grow rapidly. That means during the reionization period, our universe started to take the shape that we are able to see today. This era of reionization ended when all the hydrogen present in our entire universe became completely ionized, and our astronomers believe that this phase lasted for almost 1 billion years after the Big Bang. But recently, observations were made by J. Talweshti. The discovery revealed to us that the era of reionization ended much earlier than we had thought. The era of reionization had already ended between about 500 to 600 million years ago. And if this is true, then our models of the early universe need to be revised on a large scale. And this could become a big problem for us. Not for us, though. The results are exciting, but they're nothing short of a puzzle, not for our astronomers. When the reionization period was first studied, it was based on the cosmic microwave background, which is the afterglow of the Big Bang, and many studies were also done based on the Lyman alpha forest, which is a pattern of hydrogen absorption lines. When these two methods were combined, we got the idea that the period of reionization lasted for about 1 billion years after the Big Bang. But when Jedwabne looked even deeper into the early universe, the surprise we got is something we are not able to place anywhere on our timeline. Jedwabne's surprising findings. The James Webb Space Telescope has given astronomers the opportunity to look much deeper into the universe than ever before. We have never gone this far back in time before. James Webb Space Telescope has looked right into the middle of the reionization era. And there we have found some really surprising things. Much more than we had estimated, and much more. Extremely ultraviolet emitting galaxies were present there. These bright and energetic galaxies are so powerful that they alone could have ionized the entire universe. Which challenges our belief that the process of ionization was a very long and slow process, and that it must have ended gradually over billions of years. This discovery tells us that the reionization period must have ended hundreds of millions of years earlier than we thought. Because the presence of those very bright galaxies in the early universe indicates that those galaxies must have ionized the universe. But now the problem here is that if the reionization period ended so quickly, cosmic microwave background and Lyman alpha forest both are reliable cosmic indicators. They should have looked different compared to today. And this very difference is creating a huge tension between James Webb Space Telescope as observations and our models. Although scientists are working on finding solutions to this, but still, if James Webb's observations turn out to be correct, then questions will be raised about the models we have created. So what could be the reason for this? One possibility is that in our current models, we might have missed some very important processes. For example, recombination, where ionized protons and electrons combined again to form neutral hydrogen atoms. What if recombination was happening much faster than we had thought? At that time, extra ultraviolet radiation would have been needed to keep the entire universe ionized, which we have seen in James Webb Space Telescope's findings, and James Webb Space Telescope can explain this very well. The second possibility is that in the early universe, the early galaxies were forming. They were evolving much faster than we thought. As a result, they were releasing a large amount of ultraviolet radiation into the surrounding space. This means that whatever Jadwalski saw, it was there is an unexpected phase of cosmic evolution in the early universe. But until more data comes in, our scientists will keep grappling with these astonishing discoveries like this, because we don't have any tool available to verify the findings of James Webb Space Telescope. Because this is the first time that we are able to look so far back in time into the universe. So we hope that when we get more data from James Webb Space Telescope, then we will be able to form a definite opinion about this. Resolving the mystery. The difference between James Webb Space Telescope's data and our previously established models tells us how little we actually know about the early universe. However, the telescope's findings are sparking debate in the scientific community. For that, we need even more observations and better models that can help us understand how hydrogen recombined at that time and how galaxies evolved in that early universe. In the coming years, whatever data we get from James Webb Space Telescope and by combining it with data from future space missions, we will be able to clarify this. Whether the results from James Webb are pointing towards some new physics or not, or is it just James Webb Space Telescope? These discoveries made during the exploration are just missing pieces of a puzzle. We just have to solve them. Astronomers are especially waiting for the future survey data from the Euclid mission launched by the European Space Agency in 2023 and from the Rubin Observatory in Chile, so that scientists can find some answers to this missing puzzle from there. However, at the same time, astronomers are also re-examining our existing models to see if there is any flaw in our models themselves. For example, how much radiation was needed to ionize hydrogen? Was it less or more than the value we predicted? Are we wrong here? Meanwhile, some scientists believe that recombination must have played an important role in this process, which we have overlooked in our models. Meanwhile, some scientists also speculate that the early stars that formed in the early universe. They were extremely large and very powerful, and because of them, the process of reionization became much faster. But one thing is certain, Jadwalski has opened a new chapter in our exploration of the universe, and the debate about reionization will continue for years to come. Julian Munoz and his colleagues are working on this cosmic mystery with the hope that when new data arrives, they will finally be able to uncover the true timeline of reionization, and they will be able to take a step forward in solving this cosmic mystery. Whatever answers we get from future discoveries, they will not only reset our understanding of reionization, but also our understanding of this universe. In fact, they will further strengthen the foundation of our modern cosmology as well. This is a very exciting time for scientists. Every observation being made by Jadwalski is bringing us even closer to the true nature of this universe. Now we are able to truly understand it. And seeing this, it seems that James Webb is appearing to be completely successful in his mission. Conclusion: the results obtained from the James Webb Space Telescope have sparked not just one, but several scientific debates, which could change our understanding of the evolution of our universe. If reionization ended earlier than what our previous models predicted, then this challenges all those models and our ideas as well, which we had created based on those models, such as how the first stars and galaxies were formed and how they shaped the universe further. These discoveries show how little we know about the early universe and how much we still have to learn. As Julian Munoz explained, this is just one. This is not a case of two galaxies merging. Rather, this is a question about the evolution of the structure of the entire universe. It did happen, but neither we nor our models ever predicted it. But this is there among our current models. To resolve this tension, scientists need to work on even more detailed observations and newer, refined theories. With more missions like the Euclid mission and data coming from the Robinson Observatory, we can try to solve the mystery of reionization. But until then, the James Webb Space Telescope will continue to challenge our old ideas, and it will keep opening paths to new discoveries for us. This journey to uncover the mysteries of the universe has only just begun. But one thing is certain, we humans have never fully understood the universe. This is just the beginning of those astonishing discoveries. We still have a lot to learn from James Webb Space Telescope. The James Webb Space Telescope is the most advanced and modern telescope ever made by mankind. But it is exploring the past, our past, the past of our universe. Whenever there has been a technological advancement in human history, it has revealed some hidden things apart from the external reality of the world, things that humans had never seen before. The truth hidden behind reality comes before us, which then gives birth to many more mysteries. For example, the invention of X-rays showed people that they could see the structure of their inner body. Out of curiosity, they would get X-rays done many times, but those X-rays were slowly harming their bodies. By the time this truth was discovered, it was already too late. For them, the cancer that had spread in their bodies remained a mystery and was buried with them. Look at this painting, The Blue Room. It was made by Pablo Picasso in 1901. This painting became a mystery decades later, in 1997, when an X-ray confirmed that there was a hidden painting underneath this painting. And in 2008, with the help of the new technology of that time, that is, with an infrared scan, a hidden mystery in the painting was revealed. An elderly bearded man is sitting with his hand on his chin. Another mysterious painting was discovered beneath a painting. The hidden painting was revealed through an infrared scan, but the mystery of who the mysterious man in the painting was could not be solved. Recently, the James Webb Space Telescope has also discovered something similar. A mysterious puzzle. A red puzzle. Let's find out what was actually seen at the beginning of the universe. The James Webb Space Telescope did. National Aeronautics and Space Administration's infrared eyes, that is, the James Webb Space Telescope present in space, is the most advanced off-world observatory to date, which has been made by humans. And it has discovered something even more mysterious than the man found in Pablo Picasso. This time, we found this mystery hidden behind some faint-looking objects found in the ancient universe. James Webb's ability to peer into the early universe has shown us what existed in the early universe. Some really weird galaxies were seen that astronomers didn't know about before, and these galaxies were actually present in very large numbers. Like the man in Picasso's painting, these galaxies also appeared quite distorted, and they were packed in such a way that it seemed like they shouldn't have been there. Apart from this, according to scientists, they were in a very odd place. That's why they were named Little Red Dots or Little Red Dots. Gaia. Talking about James Webb Space Telescope, it's a powerful telescope. It can even see things that our normal eyes often can't see. It has been specially designed to study the early times of the universe. That early period of the universe when the very first stars and some of the first black holes were forming. The light that is reaching us today from that early time has become very faint, extremely faint after a long journey across billions of light years. When this light started its journey, obviously it was ultraviolet or visible light, but because of a long-distance journey and the phenomenon of expansion of space, the wavelength of the light stretched and got redshifted towards the infrared, and that's why today our normal telescopes can't see these objects. But JWST collects this infrared light and it reveals even the faintest galaxies that are far, far away to us. Because of redshift, these galaxies appear red, but surprisingly, many of these galaxies are even redder and so compact that no one had expected this. These little red dots have blown the minds of astronomers all over the world. because our understanding of cosmic evolution and LRDs has many major implications, even after their discovery. To this day, what exactly is the nature of these LRDs, what are they trying to tell us, and how were they formed? And their existence in the early universe still remains a complete mystery. It seems that these little red dots that appear red are not just because of the redshift phenomenon, but these dots themselves are also red. They are emitting a large amount of light in long and red wavelengths. Now, whatever the case may be, whether these galaxies themselves are emitting red light or the light is turning red because of the gas and dust in the way, all this is still like a puzzle for us. Besides this, their packed structure is also strange. If we compare it to our Milky Way galaxy, then our Milky Way is almost 100 times bigger than these. The average radius of the Milky Way is 52,850 light years, which is actually more than 100 times bigger. That's all we have been able to learn about these mysterious dots. With the current information, scientists have reached two kinds of conclusions. The first is that these little red dots are galaxies with a supermassive black hole at their center, or they are galaxies in which a large number of stars are packed into a small volume. But there are problems with both of these interpretations. The first clue suggests that just like we see large galaxies in today's local universe, in the same way, LRDs were present in the early universe, but at their center there used to be a supermassive black hole, exceeding our sun size by millions or even 100 million times, a colossal black hole. And we can tell this just by looking at their spectra. But there's something special about such black holes. Black holes themselves don't emit light, but these massive black holes do. Accretion, rotating in the disk. The matter that keeps getting pulled into the black hole continuously emits a huge amount of radiation. It shines with a very bright light. The astronomical spectra obtained from these galaxies can tell us how fast the matter is falling into the black hole. This also allows us to estimate the gravitational field and the weight of that black hole. These signatures were also observed in most of the spectra of these LRDs. This shows that the speed of the falling matter was thousands of kilometers per second. And this is exactly what is expected near a supermassive black hole. But now, a very strange twist was about to come in this black hole hypothesis. A mysterious thing that stunned the scientists. The light emitted from the matter that falls into supermassive black holes, which reaches us, contains a fraction of X-rays as well. This means that the little red dots should also be visible in the X-ray telescope. What if there is a supermassive black hole in between them? But scientists were surprised to see that there was no trace of LRDS in the X-ray telescope. Most of the LRDS that were discovered showed no signs of X-ray emission. This was a major setback for the black hole hypothesis. Besides this, many other surprising revelations started to emerge in the universe around us today. There is a correlation between the mass of the central black hole and the total number of stars in a galaxy, and that is, the mass of the black hole is up to 0.1% of the total mass of the stars. This correlation shows that these two astronomical objects have evolved together. But the LRDS data was pointing towards a much bigger monster. If there was a supermassive black hole in the LRDS, then that black hole would be extremely massive, which we can't justify with any current correlation. In these little red dots galaxies, 40% of the total mass of the stars was sitting at the center, dominating like a dictator. This is much more than we had expected. This sturdy early universe can play an important role in the evolution of black holes and the strange processes happening in the cosmos at that time. But how were these galaxies and black holes formed before this? This will probably remain a mystery for now, because even the James Webb Space Telescope can't properly observe that earliest part of time. But what if we move away from black holes and consider another possibility? What if these little red dots are made up of just stars? We know very well that matter falling into a black hole is much more efficient at producing light. To produce that amount of light from just stars, which we have observed in those LRDs, it would require a huge number of stars. It's like taking all the stars in our Milky Way and multiplying them by 100 times. fitting them into a tighter radius. And if that's really the case, you can imagine what the condition of those LRDs would be. If we take the sun as the center and look within a sphere of 4.2 light years, we see only one star, and that's Proxima Centauri. But if we place this same sphere in an LRDA, then in that area, not just one. In fact, more than 1 million stars would be there, meaning more than 10 lakh stars. In just 4.2 light years, that's really a lot. In today's modern universe, you don't see anything like this. So what exactly is this thing that Jade or Leslie saw in the very early days of the universe? To be honest, we don't know. They will be studied again with James Webb Space Telescope with even longer wavelengths of infrared so that we can get a clear indication about its structure. Furthermore, proposed next-generation high-resolution X-ray observatories like EXIS will conduct deeper X-ray observations. And then it might be possible that we can detect some high-energy photon coming from the little red dots. But for now, JavaScript Object Notation Web Token has opened a box of mysteries from where only mysteries are coming out. Just like the mystery that came out in Picasso's painting, I am human. In the same way, these LRDs are also a mystery for us. And maybe this mystery is trying to tell us an unheard story? That in cosmic history, there are still many chapters left unexplored. With time, scientists will try to understand it, and there will also be efforts to fit it with our current science. But just think, we've only just begun to understand this universe. There are countless such mysteries lost in every dark corner of this universe. Friends, what do you think about LRDs? Do let us know in the comment section.